In this lesson, we're going to be looking at the fourth and final method that we can use to solve systems of equations. This fourth method is called the elimination method, and we use the elimination method when we have no variable that's already isolated in our equations. So here is an example. We have two equations. The x is not isolated in either one, and the y is not isolated in either one. So we don't have a y equals or an x equals equation. So when that happens, the best method to use is the elimination method. When we're using the elimination method, our goal is to eliminate one set of variables. So we're going to manipulate our equation so that either the x's are going to be eliminated or cancel each other out, or the y's are going to cancel each other out. The steps for doing that are described here. So step 2, 3, 4, 5, all the way up to step 6. But I'm going to illustrate them with an example. Keep these steps as reference so you can go back to them and look them over to remind yourself of how we solve these problems. So they're there for you to have in your notes, and I'll be discussing each step as we do the following examples. Let's look at our first example, example A. So here we have our two equations. We can see that neither the x and the y are not isolated. So we can't use our substitution method or our comparison method very easily. So we're going to use our elimination method. So my first goal is to figure out which variable am I going to want to eliminate. Do I want to eliminate the x or do I want to eliminate the y? The way we're going to eliminate them is we're going to make sure that the coefficients, the numbers in front of the x's, are the same and have opposite signs. Or it could be the numbers in front of the y's. We're going to want them to be the same but have opposite signs. Well, by looking at what we have here, we can see the x's have opposite signs, different signs. So it's probably best to try to work with the x's since their signs are already opposites. What we're going to do now is we're going to make the coefficients, these numbers here in front, be the same. So what do I have to multiply this negative x to make it negative 2x so that it has a 2 in front of it? Well, we're going to multiply it by 2. So I'm going to multiply the whole equation by 2. So now my equation becomes 2 times negative x, that gives me negative 2x. 2 times y, that's plus 2y. And 2 times 1, so that equals 2. So that's the first equation. The second equation doesn't need to change because now we have a negative 2 and a positive 2. That's what we want. We want the same coefficients in front of the same variable. So I'm going to rewrite my other equation just below it. We want to line them up so that we have x's over x's and y's over y's. Now I have my two equations. Now, in order to eliminate the x, we're going to add them. And this is why it's so important to be lining them up. So we're doing negative 2x plus 2x. That gives me 0x. I'm writing it down just to illustrate, but you don't have to write it because it's just 0. It just cancels. Then we have 2y plus 3y. That gives me plus 5y. Equals 2 plus 13, that gives me 15. Now, well, let's get rid of this 0x because it's 0, it's just canceled, it's nothing. So we have 5y equals 15. Now we solve for y, so we divide both sides by 5. So we have y equals 3. Great. Now we need to find x. We'll use the same method that we were using before. You take your y that we just found and you substitute it into either one of the equations. It doesn't matter. And you solve for x. So I'm going to substitute it into the first one. So my first equation was negative x plus y. Well, instead of y, I put 3 I just found equals 1. And we solve for x. So I'm going to subtract 3 from both sides. So I have negative x equals negative 2. And then I have to get rid of this negative in front of the x, so I divide by negative 1. So I get x equals 2. So the point of intersection, or the solution to this system, is the coordinate 2, 3. Now let's look at example B. So I'll ask you to, actually I'll start this one for you, and I'll ask you to finish it. So let's take a look at these two equations. We don't have the same coefficient on our x's. We don't have the same coefficient on our y's. We're going to need to make them the same with opposite signs. So the easiest one to work with here would be the y's. All we have to modify is this expression. We need to make this become negative 3y, because we want the signs to be opposite and we want the same number. So what I'm going to do is I'm going to have to multiply this equation by negative 3. So negative 3 times 5x gives us negative 15x. Negative 3 times y gives me negative 3y. And negative 3 times 30, so that equals negative 90. So that's that equation. Now the first one we didn't have to modify, so I'm just going to rewrite it below. 2x plus 3y equals 25. So they're lined up properly, and now we add them. So negative 15x plus 2x, that gives us negative 15x plus 2x gives us negative 13x. Negative 3y plus 3y, that's 0y, it's gone. I'm not going to rewrite it. And then negative 90 plus 25 gives me negative 65. Take a minute and finish this one on your own. Pause the video, please. Finish the example. Okay, I'm going to continue. So we divide by negative 13 on both sides. So I get x equals 5. And the last step is to solve for y. So I'm going to take one of the equations. I'm going to choose this one because it looks a little bit simpler. And I'm going to replace the x that we just found with 5. So 5 times 5 plus y equals 30. 5 times 5 is 25 plus y equals 30. We subtract 25 from both sides. So I get y equals 5. So my solution is the 0.55. Now let's look at another example, example C. This one's maybe a little bit more complicated because now we don't have any variable that's on its own. So we're going to have to multiply both equations by something to make the variables the same. So you need to decide, are you going to try to make the x's the same, or are you going to try to make the y's the same? You can choose the ones you want, but remember the signs also need to be opposite. Well, since the y's are already opposite signs, I'm going to work with the y's. So I'm just going to underline the y so we remember that's what we're working with. So I'm going to have to multiply them by something to make the coefficients the same. Well, the easiest thing to do usually is to just multiply them by the opposite number. So this, I'm going to multiply them by, it's kind of like finding the common denominator. I'm going to multiply this by 2, it'll become 10. I'm going to multiply this by 5, it's going to become 10. So my common coefficient is going to be 10. So I'm going to multiply this equation by 2. I'll do that first. So that equation becomes 2 times 2 gives me 4x plus 10y equals negative 8. And then the bottom equation, I'm going to multiply that by 5. So that equation becomes 15x. Sorry, that should be minus, oops, let's erase that. 15x minus 10y equals 65. Now we solve it the same way. So let's just double check. The coefficients are the same and they're opposite signs, so it's ready to go. So we add them. So we get 4x plus 15x, that's 19x. The y's cancel. 10y minus 10y, it's gone. and equals 57. Last step, divide by 19. So x equals 3. What I would like you to do now, I'd like you to finish this problem. It's not finished. You still need to solve for y. And then our extra question today is going to be example D. I'd like you to solve this question. 5x plus 8y equals 29, and 3x plus 6y equals 21. Copy it down, please, and solve it. I'll check that in class tomorrow.